All right. So our last type of standing wave are when it's an open one end resonator. And this is how woodwinds work. And they're going to look something like this. And at one end, you're going to have a node because it's closed. And at the other end, you're going to have an antinode where it's open. And so the simplest one I can draw for that is like this. So this is the first harmonic. And there's going to be one important difference. If I take a look, there's a full wavelength. Okay, now this is only going from the midpoint up to a maximum. So it's about this far. It is that far. Okay, so that's only a quarter of a wavelength. Or in this case, if that length is L, the wavelength of the first harmonic is going to be 4 times L. For the other two types, you remember it was 2 times the length. So this one's a little bit different. And we're going to call the frequency of that one. The frequency of that one's going to be F1. Now, the next one we get, we're going to add a node. So I still have one node at the end, and I have a node out here someplace. And it's going to look like this. Now, looking back over here, that shape where I go from the midpoint to the top, back to the midpoint, and to the bottom is 3/4 of a wavelength. So for this one, this was a quarter wavelength, this is 3/4. So wavelength of this one is going to be 1/3 of wavelength 1. This is actually the third harmonic. Because of that 1/3 feature. And there is no second harmonic. And the frequency for this one is going to be 3 times the fundamental frequency. So that's why it's called the third harmonic. Even though it's the second one that's generated, it's considered the third harmonic because the frequency is 3 times as big. And then the next one after that, add one more node, something like this, and I get this shape. And again, this is, if I divide it into quarters, it's 1, 2, 3, 4, 5 quarters, whereas this was 1/4, so there's a factor of 5 in there. So the wavelength 5 is equal to 1/5 of wavelength 1, and frequency 5 is 5 times the fundamental frequencies. This is the fifth harmonic. So there are two differences between these open one end and closed both ends or open both ends. One is that the first wavelength is 4L instead of 2L, and the second thing is there are no even harmonics. Only the odd ones, 1, 3, and 5. So I made up this generalized cheat sheet that we can use to kind of put this all together. If I have something that's closed both ends, the fundamental frequency is going to look like this. And if I call this L, lambda 1 is going to be 2L because I'd have to go twice this far to get a full wave in. If I'm open at both ends, just have one node in the middle. And again, going from the top to the bottom is half a wavelength. So again, if this L, wavelength 1 is going to be 2L again. But if it's closed at one end, it's going to look like so. But now I've only got a quarter wavelength. I'm going to have to go way over here to get a full wavelength in. So the wavelength one for this one is 4L. For the second, I just add a node, and it looks like this. And the frequency is equal to 2F1, and the wavelength is equal to half wavelength 1. Okay, and that's going to be true for this one as well. Here I'm going crest to crest, that's one whole wavelength in there. All right, and does not exist for close one end because it's an even one and only odd ones exist. Then for the third, frequency is 3 times F1, and the wavelength is 1/3 F1. Oops, sorry, wavelength 1. And this one is going to look like this. And this one's going to have 3 nodes and look like this. And for this one, the third does exist. And it's going to look like so. All right, but this rule is still true, that the frequency is going to be 3 times the frequency of this one up here. And then for the fourth, frequency is 4F1, wavelength is 1/4 F1. It's going to look like this. And here it's going to look like this. And it doesn't exist over here.